Welcome to Portfolio, Stories, Science and Success, a podcast where we explore inspiring journeys, groundbreaking research, and the people shaping the future of science.
Hi everyone, welcome to Portfolio, Stories, Science and Success, the podcast created at Łukasiewicz Port Research Institute, where we bring stories from scientists who shape the future of research. In each episode, we'll explore journeys, challenges and breakthroughs of both young and established scientists who push the boundaries of our knowledge. I'm Katarzyna Terejko, I'm a neuroscientist myself, and I'll be the host of today's show. For our very first episode, we are thrilled to have Dr. Ali Jawaid, who is a physician scientist, and his career spans across 3 continents. Ali was originally trained as a medical doctor, but then he transitioned into the neuroscience research, earning the title of MD PhD at ETH Zurich. Ali's work focuses on 2 critical areas: transgenerational trauma, how life experiences impact future generations biologically, and the paradoxical role of metabolism in ALS and FTLD prognosis. With over 90 publications and nearly 5,000 citations, Ali has made significant contributions to neuroscience, but he is also a firm believer in being 100% scientist, 100% human. In this episode, we'll dive into his journey, his research, and the reality of being a scientist in today's world. Let's get started. Hello, Ali. Thank you for being here.
Yeah, thank you very much. Thank you very much, Kasia. It's definitely an honor to be here.
Oh, thank you. Thank you so much for accepting this invitation for our very first episode. So, Ali, your career has taken you across Pakistan, the US, and now you are based in Europe. You were also trained as a medical doctor before transitioning into the neuroscience research. And I'm really curious, what inspired those changes?
Yeah, it's a very interesting question. So I think right from the start of my life, adaptability kind of came very naturally. That's because my father, he worked for the Foreign Office. So he was constantly transitioning between different places, different cities, different countries. So as a child already, I was moving around a lot. Now that has its upside in that, every time you go to a new place, you make new friends, you have to quickly adapt. Sometimes you hear a language or accent which you're not used to, and then you try to figure it out. So there's a lot of stimulation coming. It does have its downside that you're also constantly losing friends and connections, and then you have to make new ones. So I think somewhere along the process, I realized that I'm not afraid to start something new, to move to a new place, to make new connections. Plus, science is also a career in which mobility is important and diversifying your experience is important. So you could say it's a mix of me having that kind of childhood where I learned to be very adaptable and being open to new experiences, and finally also taking a career where actually mobility is important. So this covers the aspect of how much I was moving around continents and having experience in different places. And then when it comes to the transition between medicine and science, that was purely driven by the idea that I always tell my students that medical students that if you're a medical doctor, you are you're acting on the stage. You're given the script, which means guidelines, right? Someone has identified a diagnostic, someone has identified a prognostic, some kind of therapy, and then, you're giving it to the patients. But if you combine it with science, then you're writing the script, because then you're able to actually, go to the questions which have been unaddressed, which are troubling people, which are making their lives unhealthy, or which are affecting even generations based on our topic. But then you figure out what's missing in the field, what are the questions which remain unaddressed, and how I can find innovative ways to answer them and somehow bring it back to the clinic and help people out. So I think it was driven by this motivation of finding the truth, finding mechanisms.
Wow, this is a very inspiring perspective. So, at what point did you know that you wanted to lead your own research group?
I think so for me, what was most important was leading ideas, coming up with hypotheses, finding like-minded people, and finding ways in which you have like a team of like-minded people who have the same goal and who have the same aspiration. Leading a group, to be honest, I see myself as like a team player and as someone who can define a path. I don't think that I ever saw myself as someone who would be doing a lot of administrative stuff. I never wanted to. Now you have to do it as a lab leader, but I think for me, I always wanted to be leader of initiatives and ideas. Then in science, the reality is that you have to lead your own team. You have to put together your own team, give them the vision, give them the philosophy of how you want to work, how you want to do science, and then you collectively move towards your goal. So I'm very happy that I was able to find a team like that. To be honest, I won't even call it leading. I would call it just mentoring. Wow. I have a bunch of very bright people, and I'm just there to sort of fine-tune them,
Yeah, that's great. So yeah, I completely agree that teamwork is the base of science and research. So maybe let's talk about the research itself a little bit more. Mm-hmm. Can you share with the audience how do life experiences, especially negative ones, biologically impact future generations?
Yeah. So I guess one thing which we also have to really look into is what is a negative experience, and this is something which we also try to incorporate in our research. So the topic broadly we are looking at is in one domain of our research is childhood trauma, or stressful experiences, or childhood adverse experiences, no matter which term you use. But let's say if a child has unhealthy childhood, what will be the long-term impact on their brain? Unfortunately, it's very common. I think there are stats showing that as much as 70% of the children, they undergo something traumatic, either neglect or abuse or bullying, something like that, before puberty already. Now think about all the adversity and all the stress that these children go through. So of course, what is intuitive is that it will probably shape up their behavior during adolescence and adults, and they will have some kind of risk of pathologies. Interestingly, not every child who undergoes something traumatic takes this trajectory of developing PTSD or depression, right? Some of them actually have what we call post-traumatic growth. They actually become very resilient, and then when they're faced with a stressful situation, they show a lot more resilience. So number one, we are looking at childhood trauma as not only a negative influence, but also trying to find out, in the words of Gabor Mate, the wisdom of trauma, right? So we are also trying to see if this leads to some kind of behavioral flexibility. And then we look at how these experiences, childhood traumatic experiences, how they impact the germline. So how does trauma, which is initially perceived, it's an emotional and cognitive experience. So how does that lead to changes across the body? How do these changes eventually hone on to the reproductive organs and the germ cells, the sperm and eggs, and how then the sperm and egg, after fertilization, carry these experiences to the next generation? So let's say it's very sort of directive and intuitive research in which we want to look at long-term impact of someone who was resilient or susceptible, then how do the changes translated into different functions of the organs in the body, especially how do these changes, how do these effects get imprinted into the germline, and how do germline carry it to the next generation? So this is overall, I would say.
Wow, these are very, very important questions and a very fascinating research. And on top of that, your team investigates another area, right? So your work on ALS and FTLD looks at the paradoxical role of metabolism. Mm-hmm. Traditionally, we think of metabolism one way in neurodegeneration, But I wonder, what new perspective does your research bring to that?
Yeah, so this was actually something, maybe I'll give you like little bit of the context. So I actually, after my medical degree, I trained as a neuropsychiatrist. And in neuropsychiatry, you deal with a lot of different cognitive disorders, like dementias, like FTLD, for example, leads to this frontotemporal dementia. So we were studying that. And at that time, I didn't have any knowledge about molecular neuroscience. I was just a medical doctor who wanted to answer questions and who was interested in research. So we started analyzing risk factors for dementias, and most of the times you see that diabetes, hyperlipidemia, hypertension, they're mostly risk factors, right? They usually are detrimental for our health. But very interestingly, I still remember that day that I was analyzing data and I was in some neurodegenerative illnesses like ALS and to some extent also in FTD, we see some positive effects of diabetes or dyslipidemia. So the people who have diabetes, they survive longer, they have a delayed age of onset. I went with these, with this analysis to my mentor at that time, Paul Schulz, who, by the way, I would say has been an ideal mentor, has been truly the most empowering mentor I could imagine. But at that moment, at that day when I went to him with these ideas, he was like, "What were you drinking?" Because how do you expect diabetes to be protective against something? And I was like, "No, I was opening my Excel sheets and no, look at this, my SPSS." And eventually, he was like, "Okay, so if you have shown me that it is protective, let's validate it by 100 different ways, because we don't want anyone to question this, because we are going to make a big statement." So this was actually also how I got more and more involved in research. And yeah, eventually we were able to publish those clinical papers. This finding we validated through multiple ways. But what I always struggled with was, okay, if diabetes is protective, of course we cannot expect patients, we cannot tell someone, okay, just take too much sugar and you'll be better, right? It will have its own consequences. But it provides us some kind of a lead. It shows that there's something going on, in neurons or the support cells around neurons at the metabolic level. And diabetes is turning out to be protective in some way, but if we can identify what is happening downstream of that, what is happening in terms of the metabolism in the cells, then maybe we will be able to come up with a pathway, and just by targeting that pathway, but without causing overall diabetes, we will still be able to replicate that protective effect. And this has been the other, you could say, obsession of mine, and now I have very capable team members who have driven this project to the extent that we actually have some clues about which biological pathway is affected. And maybe I would just mention one more thing, because we have a project about childhood trauma, and then we have a project which mainly is about neurodegenerative illnesses which impact not children but mostly older adults. And I think there I also have a personal motivation, because I think children and our elders, older adults, they are the most innocent and the most vulnerable population. Adults can be messed up, but children and older adults never. So I really want to do something to help them out.
Wow, that's amazing, seriously. And these are very, very relevant topics as you described. So I'm really looking forward to new discoveries. But maybe we can leave research aside for a moment, because there are so many interesting things about you as a person as well. You describe yourself as 100% scientist, 100% human, and I really wonder, what does that mean to you?
Yeah, so there's a story behind it, but that's a story which probably, I don't know, one day I will share on my retirement speech or something. Until then, I'm not ready to. But I think besides the story, it's a little bit about, I guess, some introspection. That in the end, if you do science without human qualities, then science just becomes a fishing expedition. It's about finding some data. Then you do science only for yourself, And it's fine to, we all do science to some extent to satisfy your curiosity, but, because of my work, because of the life experiences, I've interacted with humans at levels which were so meaningful, also even scientifically. For example, when we talk about this intergenerational trauma, I have directly interacted with genocide survivors. And this has been such a powerful experience which touches you, and you realize that if you do science just out of curiosity, maybe you'll be able to publish great, maybe you would be able to boost your ego a lot. But if you just add compassion to it, then you just multiply effect many folds. Then you are really immortalizing your science, because the therapies you would come up with, the new diagnostics you would come up with, eventually they will be helping out millions of people. So this has been my motivation, to actually add the human into science.
Well, I really appreciate your insights. They're remarkable. But you are also a fiction author and a poet. So how those creative outlets fit into your busy scientist life?
Well, you just need to balance, I guess, yourself. And I was always a writer. I was writing poems when I was 6 years old. I actually got my first paycheck at the age of 11 because of an article I published in a storybook for children, So writing came very naturally to me. Even at some point, I also considered maybe I should just become a writer. But when I write, it also, there's too much chaos in the brain when you're writing, That's the beauty of it. And out of that chaos, you're able to put together a story. Sometimes it's completely imaginative, right? But this is how you're able to put something together over there. So I like that chaos, but I don't want it every day. And then on the other hand, science is something which I truly love, but it's a very logical way of thinking. And if you just think logically all the time, then also you start missing that beauty of the chaos. So for me, it's a perfect balance. When life gets too sort of straight and too burdened because of science, then writing just provides me an avenue to just liberate myself and just go a bit crazy.
Yeah, so you already mentioned that science is a high-pressure world, and that's something that allows you to maintain balance and avoid burnout, isn't it?
True, for sure that, but I think, there's also some incredible power in, especially if you're doing any kind of art, if you're creating something, be it writing poetry, be it writing a novel, but it has some incredible power of healing, not only for yourself, but it actually also helps in your logical thinking. Just an anecdote, because I'm also an enthusiast about alchemy, which was, if we think about all the different fields of science which evolved during the last 1,000 years or so, then alchemy actually was the first logical science to evolve. Okay, now we know it has been replaced by modern chemistry, but alchemy was the first thing in which they actually had some kind of logic. There were formulas, there was this concept of 5 elements and how you mix them up and everything. So I've read a lot about alchemy. And there's one thing which always strikes me, that the highest form of alchemy, which is to make the philosopher's stone, right? This is what all the alchemists were obsessed about. It's called magnus opus. And magnus opus literally translates into the great art, And for me, this is a lesson which I keep very close to my heart, that actually the highest form of science is when you have abundant creativity into it, right? So when you combine art with science, that is what can lead to a true innovation.
Wow, your outlook on this is really fascinating and unique voice. So I will have another question about your science life. What has been the toughest challenge in your career so far, and how did you navigate it, if you might share?
Every day has been a challenge. So interestingly, when I talk to my scientist colleagues, they mostly say, writing grants, like raising funding, the pressure of publishing papers. To be honest, I love those things, and I wish I had more time to do those things. So it has never been like a burden for me. Like I think for me the thing which in science, like which has always been very frustrating for me, is like I'm thinking of like how to say it in a politically correct way, but let's say the way like some systems and some organizations work, in which your creativity is not nurtured, your scientific like liberty and like your advocacy and your scientific values, they are not nurtured because you're even sometimes there are too many constraints. Okay, you have this grant, but you cannot spend it the way you want to. You want to have a team member who's very capable, but then they are like, no, but like we want not this person but that person, because like for some kind of like obnoxious like administrative reasons. And I think sometimes there are great people you want to collaborate with, but then you're forced to make strategic decisions. No, we should put like a person from this country so that we become like able to apply for this particular grant. And I think science should come with like honesty and freedom. Like if you have a good idea, if you are able to convince a group of experts through a grant that that we are the right team to do this grant, then I think then you should have some flexibility on how you want to do the things. You should have deliverables, you should have targets. Okay, by this year try to figure out this question, but don't force us to make decisions which we don't want to.
Yeah, I understand, and I see the connection between writing grants and writing fiction in a way, if we can put it that way. And your opinions and your experience can be so valuable. So I know that you've mentored many young scientists, and maybe to them, what's one common mistake that early career researchers make?
I think, like again, like if you would ask like some of my scientist colleagues, they would answer things like you have to find the right mentor and like this and that. But like I think for me, like nothing should be seen as a mistake, but a few things which young scientists sometimes like are unaware of is how the life of a scientist would look like, right? I mean, and again, like if your ambition is to win the Nobel Prize, there's nothing wrong with that, but you should be aware of the sacrifices you will have to make to do great science, like and if your ambition is actually to do meaningful science which would make an impact in the world, then I think it gives you bigger motivation to make those sacrifices and to deal with things which can be like extremely burdensome and extremely stressful. I myself could say that there have been moments like in my scientific career where I was very close to a burnout. But then there could be like one question, like, which a young student asks you, and it makes you start thinking, and then that gives you the motivation to do your science. Or there could be like, an old student of yours, they write you back and they say how like, a little trick you taught them about doing data analysis, they are still using it and they want to thank you for that, and that motivates you. Or you would talk to, for example, in our research, like, I was recently, for example, in Rwanda, and I met like a genocide survivor. He's a film director now, and he told me that our research gives him a lot of hope, because he thinks that when we are doing this research, someone is listening to his story, someone is listening to his traumas, and someone cares about that, and someone is trying to figure something out to help them. And these things keep you like very motivated. So like my advice to young scientists would be just think about the bigger implications of the questions you want to address, because that will give you the motivation to deal with all those sacrifices which will come along the way. If you would just do science because of some ambition of doing something grandiose or winning a prize or whatever, again, I'm not going to judge, but then there will be moments when you will have failures, when you will be very close to a burnout, but you won't have this, resilience, reserve, and this motivation to counter those in the healthiest ways. Another thing which I see a lot in young people is that don't follow trends. Don't think that if virtual reality was hyped up like 5 years ago and AI is hyped up now, it doesn't mean that this should become the purpose of your living. You can answer very difficult questions sometimes by using very simple techniques. The beauty of science is breaking complex things down into simplicity rather than using something really fancy to answer a question I had also a very interesting mentor in Zurich, and he used to say that if you see a horse and a zebra standing together, you don't need to genotype them to tell which one is zebra, so yeah, this is the point which I want to address. Yeah.
Okay, so this motivation is really important to make this job enjoyable, right, and sustainable. And to those young researchers, maybe now in the labs, do you have one simple advice for their career, how they can move it forward, or how they can think about moving it forward?
I think I would say that this should just allow themselves to have different experiences and make some kind of comparative analysis in terms of what feels most rewarding to them. Again, just don't follow a trend because that is hyped up at that particular time point. Think about what feels most rewarding for you, right? I mean, and again, for example, not everything has to be addressed by AI, not everything has to be addressed by machine learning, not everything has to be addressed by, I don't know, some fancy equipment which costs millions of euros, In the end, sometimes you will get answers just by reading somebody else's work, and then you have to put the pieces together and do the proof of concept experiment to figure it all out. So again, my advice would be to think about what feels most rewarding for you, what actually motivates you, what would make you wake up every day and go to the lab, even though there will be failures, and finally keep things simple and don't follow these fancy trends.
Okay,
but you can follow trend because that's the name of our lab.
Yes, exactly. So the trend name stands for?
It's Translational Research in Neuropsychiatric Disorders. That was the original idea. There's actually a funny story about that because I always wanted to do translational research and on neuropsych disorders. So the original name which I came up with was Tender. But then one of my friends was like, Tender sounds too similar to Tinder, so no, that's not gonna be good. And then I was like, okay, so what should I do? And eventually, with the advice of this friend of mine, we were able to come up with the name Trend. And then, then I loved it, and I'm still keeping it. Yeah.
Yeah, it stands out for sure, and it's a great name. So amazing. Finally, Ali, where can people follow your work and learn more about your research and the TransLab research?
Well, we are actually quite active on socials. I mean, the whole idea for that was, again, just we want to show young scientists that scientists can work on very difficult topics, can have a very difficult life, but still what bonds them together, what unites them together is that they have common goals, they have common values, and they can live like a family and have fun. So if you look for Jawaid Lab on Instagram or some of the other socials, you will find pictures and reels from our retreats, all the things which we do together. And yeah, I think this has been the best part of science for me, to have a team where each individual, interestingly, for me it feels I'm in a forest where each individual is like a tree which gives its own fruit, and that is very beneficial for our science. But I feel in their roots, in their values, they're connected together. just how trees in a forest are connected together at the root level. So yeah, you can just look for Jawaid lab.
Yeah, but that's a very beautiful analogy. So thank you so much for this conversation. It was amazing. I feel like I learned a lot from you. And to our listeners, thank you for tuning in to our first episode of Portfolio, Story, Science and Success, brought to you by Łukasiewicz Port. We'll be back with more conversations like this one. Until then, keep exploring, keep questioning, and keep pushing the boundaries of knowledge. See you next time.
Thank you for watching and see you in the next episodes.